So yesterday we were actually, we started with microservices definition. Before that, we tried to, look at what exactly we are going to learn out of this training. Then we started with microservices definition. Today, mainly, we will just dig a little bit more into deeper on the microservice definition and concepts. Then we jump on to our Spring Boot explanation, where I would like to give some basic Spring knowledge as well. So then we'll try to end this session with by executing our sample Spring Boot example. Of course, yesterday I had a couple of questions like one of you asked why we should be going for microservices when we have other architectures as well. We do have a very detailed mm, you know uh, explanation or session plan on looking at why actually we should use microservices. So that will come back to that topic. But we just wanted to let you know that we'll be discussing on that part as well. Why would be using microservices? But today let's take our discussion to microservices introduction. Then after microservices introduction, we'll jump on to Spring Boot straight away. So we don't want to stick with completely with conceptual discussions entire session. So every day we just try to execute at least one lab session so that we are consistently doing the concepts explanation as well as lab exercises. So today, that's what my plan is. So we'll complete microservices introduction and then jump on to the Spring Boot. So, so as we have seen yesterday, so basically the microservices, now we know that microservices is basically an architecture, and compared to the monolithic architecture or the traditional legacy architecture, where lots of Java-based application have already built upon using monolith architecture, the current industry is looking towards microservices architecture, which actually tells you to develop an application as a group of services. There was also a question on SOA, which is service-oriented architecture. So SOA is also something similar to microservices, where it also asks you to develop an application as group of services, but there are again some limitations with SOA. We are going to discuss that. We are going to compare SOA and microservices. So SOA, we can, for now we can assume it's a kind of midterm architecture between legacy or monolithic architecture. When I say legacy or excuse me. So when I say monolithic or legacy architecture, I mean the general three-tier architecture. So most of you guys must be knowing MVC, at least MVC pattern. So most of Java JT applications and which are currently into production generally on MVC architecture at least, otherwise three-tier architecture. So three-tier architecture you guys must be knowing. Then microservices architecture we are comparing. In middle we have something called SOA, which is of course I would say didn't gain lots of markets attraction because it has lots of cost involved, lots of complexity involved. But still, there are clients which who actually likes more SOA compared to microservices. That's a different topic altogether, but still to understand our microservices concepts will try to compare microservices with SOA as well, which is service oriented architecture. So here three types of different architectures we are actually discussing. One is the three-tier architecture or the legacy monolith architecture, then the midterm SOA, service oriented architecture, then microservices. So for now, microservices, what we have in our mind is microservices is nothing but developing an application as a group of services, and also taking very much care of these services communication, and also taking very much care that each services is independent of other in development, deployment, not in running. So there was a question in my demo, how come services can be independent of each other? Services are always dependent. One service requires information from other service. This dependency is actually very tough thing in developing any software application. So dependency management is, it's actually uh, mm, it gained so much attraction by lots of developers, and they try to address this dependencies management between services, or I would say rather, if it's a three-tier architecture between modules at least. Let's say traditional e-commerce application, so maybe customer module is dependent on order module may be dependent on product module. Let's say if you want to confirm an order, right, so which generally in a traditional three-tier architectured e-commerce application, so from the order class you may be invoking a method in the product class to get the product details, let's say, so that you will include it in your order. So order class generally may be creating a product class object. For now, we are assuming traditional three-tier e-commerce application where we have a customer module. I'm saying customer module here because I'm following three-tier architecture. It's not a customer service. For now, let's talk in terms of modules. So I have a customer module where I have my customer class. Customer class provides different services like adding a customer, removing a customer, getting customer address. Let's assume this thing in customer class. Order class then. Let's assume order class has different services like confirming an order, creating an order, removing an order. So these kind of services in order class. Product class maybe to give the product details. So you may be having some kind of method like get product details by ID, right? If you give a ID, product ID as an input parameter, as a method parameter, maybe that method will return all the product details. What's the product name? Who is the owner? What's the MRP? What's the discount? All that stuff. Let's assume in product class. So product class provides these services. Order class provides all the services we discussed, and similar way customer. So at any point of time, these three things are interdependent. Not only in the traditional e-commerce application, whatever the application you generally take, generally we talk in terms of modules, and each module contains their own classes, and one class is dependent on other classes. So this dependency management, in a way, beginning from the beginning of software development, this dependency management generally day by day, becoming complex, and there were some solutions which is, where, Spring is one part, right? Spring actually, the core concept of Spring is maintaining the dependency, right? So of course, we are going to talk about in a few minutes on Spring. So here, we take like this. So always the modules are dependent on one module is dependent on another. Similar way, services are dependent on other, right? So one service may be looking for some other information in a different service. So now if you deployed them as a separate services, they cannot work independently. But here the main concept of microservices, the architecture that you are adapting allows you to develop these independent services, sorry, these dependent services in an independent way, and also to deploy an independent way. So to develop customer service, let's say you need not complete the order service, or let's take this way as well, as we just discussed example, to complete order service you need not complete the product service. For example, in order service, let's say you have a method called create an order, otherwise confirm an order. So for that you need the product details. So where you may be writing in one line of code saying, okay, I want the product object here. Otherwise, I need get product details information from the product. So I cannot proceed further writing this method, creating order method until this product is completed, right? Product method, the get products method is completed. So that is not the way. in maybe in the traditional way, this could be a blocker, but in microservice that doesn't block you. Basically, you'll generally you something called contracts in place, already in place when you're developing a service, product service. In well before the development, well before starting the development itself, you will just assume some contracts. Okay, product service will be returning this details, the product details, with this kind of format when you invoke particular URL, let's say, right? Generally, when it comes to the services, you know they talk in terms of URLs here, the web services here. We'll just slowly get into this the things when we run an example. But for now, let's assume, this is how, the microservices architecture makes our development independent, compare, from service to service, right? Development and deployment independent from service to service by defining some contracts, right? So that's how, you follow when you adopt microservices architecture. Beginning of the development itself, you'll define some contract, and based on that contracts, you keep developing your own service, right? So we'll again jump onto this contracts creation and all that stuff. But for now, microservices is developing an application as multiple services, and and also in a way that they are independently developable, independently deployable. So we can also look at microservices architecture is one particular form of SOA, which is service oriented architecture. So we'll again come back to this point. What is service oriented architecture? So loosely couple SOA. Generally, the SOA, the original SOA is tightly coupled. So how it is tightly coupled, we'll discuss. For now, microservices architecture is one form of SOA where all the services in SOA again, SOA also tells you to develop your application as group of services. So far, we are developing as our application as one project having group of modules. Now multiple projects, that is group of services. So right, so let's try to compare these things. So how traditional three-tier approach was and how the microservices are going to be. Excuse me. So if you look at the left side of this image here, microservices approach and traditional three-tier approach. So you may be seeing in three-tier approach or maybe in a single process approach. So everything is running on a single container or single process. But here on the left side, you will have multiple services. So in three-tier approach, as we just discussed, generally you talk in terms of modules. So each of container may be executing multiple modules, but end of the day, they are part of one container, one single container. So they are tied up in a one single container, maybe one single server, let's assume for now. Oh, right. Sorry, my screen got lost. Looks like. So you able to see my screen now? Still not?
I can.
Okay, I just reshared my screen. Right. So this is where I was actually discussing a three-tier compared to the microservices. So generally, let's again compare this with our regular traditional e-commerce thing. So on the left side, you have monolithic architecture. So where you have all the three modules, customer module, otherwise customer service, product service, cart service, running on a single container. It's a single instance. All three are running on the same WAR file. Whereas in microservice architecture, you will try to separate the commonalities into a different microservice, generally the UI part. Okay, so then the actual business logic of customer, product, and cart you will be running as separate instance. They are not of single instance, but whereas in monolithic architecture they are single instance. That means, so this server is running all the three modules, all the business functionalities related to the customer, all the business functionalities related to the product as well as cart. They are running in a single var file, maybe a single jar file. But here customer has its own, customer is a separate project, product is a separate project, cart is a separate project. Let's see in future, if you want to add one more customer here, so you can just add, you can just take customer code and you can create a new server, and you can just start executing customer service again. So in that case you will see two customer instances here, but that is not possible in monolithic architecture. If you want to create another customer instance to manage your load, let's say, so how do you manage the load generally? It's all regular routine way, right? For us, once we have our application developed, we may be running it on multiple servers, multiple application servers, multiple javas or multiple WebLogic servers. And how do you manage the load? So again you'll deploy some web servers, maybe Tomcat, in front of your application server. So these web servers, you'll create on the web server, you may be creating some logic so that this web server will distribute maybe first request to the first application server, second request to the second application server. So that way you generally manage in your production, right? So similar to that. But here what happens is each of your application server running all your modules, but in microservices you can actually, you're running all the modules as a different servers, right? So that makes that makes it easy to scale up a specific service. One of the benefits of microservice we are talking about. But for now, the thing we need to understand is, so this is not a single instance here in microservices architecture. So each of the module runs as a separate project on a separate server, whereas in monolithic, all the modules runs on a single server, on a single project. So what's the problem with monolithic architecture? Why shouldn't we follow? Let's try to, other than some benefits, there are lots of benefits here, lots of challenges. So that's where this, why microservices comes into picture. So lots of challenges in monolithic architecture which we want to discuss, and lots of advantages of microservices. So that's, we jump back again. But for now, just to complete this slide, so the basic thing is decoupling versus scalability. That's the main challenges that current industry is facing. Let's say I'm a client and I have an application developed. So as the business is growing, I may get so many customers, the user requests may get increased to my application. So I'll get into a stage where running one application instance is not sufficient to serve all the user traffic. So that's where I'll go to my software vendor and I'll tell them, okay, let's uh, run another instance of application to manage our traffic. Then immediately the ask would be how many servers that you are ready to buy, right? So then the ask would be, okay, what is the capacity and all. Maybe the answer would be, as our application is very much big, you may need to go with this kind of high-end configuration, all this stuff. So that's something, blocking the customer or clients to scale their application. So not easily scalable, because you need to run your entire application, you need to set up entire application irrespective of the particular area that you see more traffic. You may be seeing the traffic only on the customer module, right? Maybe more users are getting registered to you. They might not have started you know purchasing the products. Window shopping generally you will see, right? more people have a tendency to log in, maybe let's say Amazon.com or Flipkart, will just keep browsing, right? So where only, so let's say if it's all a window shopping, let's say if users just logging in and browsing, so only two services are functioning there. One is user login function, which is taking care of user session and all. The other one is products. So orders is no way get hit there, right? At least more than 60% of traffic. But you still, on your server, if it is a monolithic architecture, you still have your orders running. And if you want to scale up, let's say if you develop in a monolithic way, you will scale up order service also, but you may not be seeing orders has much traffic. you know Maybe 100 people out of 100 people logged in to Flipkart, only 20 or 30 people will end up buying. So remaining 70 is, they just create traffic to the customer service or else the product service. Order service, anyhow, those 70 people are not creating any traffic. But if you develop your application in a monolithic fashion, right, so order service will also consume some space, right? So because to scale up, to run your application on a different server, again you need to take, because you cannot bring out order module out of your var, because order module is tightly coupled there, right? So that way you actually develop your in your monolithic architecture. So unnecessarily you are spending some resources on order, right? So this is where this tightly coupling and scalability issues comes in. So this is just three modules we are talking about. In real time, there may be 100 different modules or 100 different services where only 20 services are seeing the traffic. If all these 100 services are tightly coupled, and if you want to scale up only those 20 services, that may not be possible. Every time you maybe end up running, creating a very big server, a server of very high end configuration, and running all the 100 services, where 80 services are sitting idle, only 20 services are serving the traffic. So that's actually becoming a problem. So this tightly coupling and the scalability is becoming more challenge. So that's where users started moving from three-tier architecture to SOA, where SOA is little bit less tightly coupled. That means more decoupled, right? Less tightly coupled or decoupled. So both are same, right? So three-tier architecture, generally you end up creating an application which is more tightly coupled. That means you cannot actually run a module independent of other. If you want to scale up a module, if you want to run one other instance of customer module alone, you cannot just do that. You may be building entire application again. You may be running another extra product module as well as order module along with customer module. So that's how the things get shaped in, if you follow three-tier architecture. Let's say customer service, product service, card service. If I want to deploy another server, that server will also run product service, card service here, if you follow monolithic architecture. So this tightly coupling is somewhat resolved in SOA, where in SOA also, SOA is basically you divide the services. But again, what happened in SOA is the services are decoupled, but end of the day, as per the SOA architecture, they communicate via a common medium, which is called enterprise service bus. So every service you develop, they will get attached to one common transport medium called enterprise service bus. They talk by messages in SOA, service oriented architecture. So that's again introducing some coupling there, coupling to the service bus enterprise. So what now you in when you adopt SOA, so what you do is, so you again from, instead of developing as three modules, so you develop this e-commerce application as three services. But how do you communicate between these three services is, in SOA you just go and attach all the three services to a common message bus. Let's assume if that message bus is down, so that service is gone. Otherwise, let's assume if you just want to deploy, or if you want to scale up another customer service, you want to bring up another customer service running, so you may end up creating service bus as well, another service bus. But more than this case, let's say the coupling is introduced between the by the way the things are communicated, the services are communicated in SOA. So in SOA, what should come into your mind is it's still a number of services, but these services cannot communicate independently. Sorry, individually they cannot communicate it. They can communicate only via a common message bus or a common enterprise service bus. That means a common road. Let's assume if that road is gone, that communication is gone. So those kind of, again, little bit complexities are there in SOA. That is completely addressed in microservices. So microservices is completely decoupled. So and you completely scalable with less resources. Easy to scale because uh, if you want to set up a new customer service, maybe customer service will have, let's say, if you want to set up entire three modules, you may end up doing lots of configuration because product service may be having some configurations in the production, car service may be having some other configurations, but you cannot run a new instance of customer service alone. If you want to run a new instance of customer service, you are forced to run product service, also car service. So that's where you cannot just leave them without configuring. So you again start up configuring product service, unnecessary development effort. You will start configuring card service. In the production you may have lot many configurations, right? Some property files, this property, all these things. Dev properties. What is the production properties? So much configurations you have. If one model is running, you may have much configurations. So which you are unnecessarily doing lots of development effort. Assume if you are able to just run customer microservice, an extra instance of customer microservice, so you will end up doing only customer configurations. So that's a reduction in development effort. So these things are there. So compared to monolithic SOA and microservices. So basically, for now, the next point we understood is, compared to the monolithic architecture, in the form of decoupling, in the form of scalability, microservices is more efficient. With monolithic architecture, you cannot scale that easily. You cannot decouple that easily because the development style itself is like that. If you follow monolithic architecture, you cannot do decoupling. The monolithic architecture tells you to just separate presentation, business logic. That's it. All your business logic should be at one place. That means they are tightly coupled. Customer business logic is tightly coupled because they are at one place, running, adjacent to each other. That's where this coupling gets introduced. But come when shifting from three tier to SOA and SOA to microservices, this is reduced. The coupling is reduced. That is more decoupled. And when coupling is reduced, when they are loosely coupled, it automatically it automatically solves the scalability issue. You can just scale up or scale down as per your requirement. Today, maybe tomorrow, let's say Flipkart is launching some free registrations. Assume we have some paid registration. It's a free registration for next 2 days. So for next 2 days, Flipkart may be expecting so much customers login. So in that case, Flipkart can just run three more customer services, right? So that additional traffic will be taken care. Once that offer period is over, they can just again scale down the additional three customer services which they are running, so that they save their resources. That way, maybe they have a for last, let's say, five, so much offers is going on. This is a weekend, right? Sorry, this is a year end. So these during this period, generally they will be expecting more traffic. more orders, so they may want to just make sure they don't want to miss orders, so they may just if they have followed this microservices architecture, they can just create 4 or 10 more order services, and once the offer period is end, they can just scale down. So just bringing up the order service doesn't, four more instances of order services, doesn't take more effort if it is a microservices style. But if it is a single instance, they'll end up creating lot many other, again big projects, again lot much configurations. That's where main, these are the main things that actually um, uh, actually served as a reason to get into evolution of microservices. So that's why let's start this discussion here, introduction to microservices. Let's jump back again, right? So for now, what we have in our mind is microservices is this, creating an application, multiple services, and services communication. Compared to SOA, now we have an additional point. In SOA, services are communicated via a common medium, but in microservices that doesn't take place. Services communicate individually via something like REST web services or a web service, mostly REST web services. So what is web services? REST web services we will see again. So having looked at that, so let's come to the Spring Boot. So to develop this kind of a style in Java, so what do you have? So what are the things you have in Java? So for now, okay, now I don't want to develop my application as a single big project. I want to develop my application as multiple services. But what do I have in Java to adopt this fashion, to make it easy developing in this way, in this architectural style? Yeah, we have multiple frameworks. Spring Boot is one thing. Additional to Spring Boot, we have something called Drop Wizard, which is again Java based, and Wildfly Swarm also again Java based. So, but for now, this training Spring Boot actually gains more, more market compared to the other two things here mentioned. So Spring Boot is basically, it's not a framework, it's basically a tool. Spring is a framework, I would say. Spring is a framework and Spring Boot is a tool. So we'll just try to compare what is Spring and Spring Boot also. And then, okay, I will develop my microservices. Then we also talked about communication. In SOA, okay, although we understood, okay, one, even you develop your services, so that they can independently develop, independent, they can be run independently, they can be deployed independently. But end of the day, what do you do in, if it is a service oriented architecture, this OA style, you go and uh, you know pin your service to a common medium, common communication medium. But doesn't that shouldn't be taken place, right, in microservices. Then what is the thing in Java to make a light way of communication, as we just discussed in our definition? So we have something called web services. And again, in web service is basically a concept, right? So web service, it tells you, a communication, a way of communication between application, which are running on two different servers. Let's say if you want to communicate between um, uh, your application, so what they tell is, you write a web service, you write a method, you call it as a web service method, and you can invoke, if you follow web service style, you can invoke that method which is running on one server, right? So let's say server 1 is running method ABC, server 2 is running method, let's say XYZ, and ABC has a requirement for XYZ method. And if XYZ is a web service, they can just invoke between services in the form of URLs. That's what the web service concept is generally. So here, that concept is basically, we have some libraries to implement that concept. So that is nothing but JOX RS. So it's an open source framework again, it's not a paid version. So we'll see what are the different APIs we have in JOX RS. So using Jersey or JOX RS, so we'll create a communication between the services. How do we create communication in SOA? So we just discussed there is something called enterprise service bus. There are enterprise service bus providers in the market. Different vendors are there, so you can just take any of their product and implement your enterprise service bus. What it will have some methods, maybe some methods or some APIs, so that you will attach your services to the common enterprise service bus. Then enterprise service bus will take sending a message from one service to the other service. Maybe AB, some customer service is sending a message to product service. Hey, give me a product details, all the products. uh, you know Maybe, hey, I see a so and so product IDs are ordered by this customer. Can you give me the product details? So these are the product IDs. Maybe this message, customer service is talking to the product service. So this message communication, enterprise service bus will be taking care. But here we'll just try to establish this communication in an individual way using this kind of an APIs. Basically, web services dependent again. There is something called web service. Again, you'll slowly get used to these terms. So don't worry if of course, mm, for mm, mm, for most of you, I think you are already aware of web service, but still, okay, it's okay. We are going to create a sample web service so that you'll get more deeper understanding. And there is something called Swagger. Okay, this is also, maybe we'll jump back again. So basically, this is to document your API. So what is the requirement for documenting your API is, let's say now we mentioned a point saying, okay, now my team is taking care of developing customer service. Maybe other team is taking care of developing product service. So customer service at one time may be dependent on product service. So there should be one document which I can refer, so that how I can, that document should be telling, so what is the URL that I can use in my customer service so that it will go and hit the product service, and also what is the format that that product service will respond. Let's say I want to get the product details. What is the format? That product will be, maybe, what are the different fields? What is the, what are the different fields that product service is going to return to me? Maybe it will return the product name, product description, product weight, product warranty, all this stuff. But how do you know? Because I am not complete into product, right? My team is different. My team is customer team, so I only know customer, all the related customer related functionalities. So that's where you can, if you documented your API, if product team has documented, okay, we are going to develop this kind of an API. This is the URL, or this is the input, this is the output. So then you'll go and refer that document, and based on that document, you'll just, oh, okay, if I call this kind of a method, okay, I am going to get these details. So then now I'll create an object so that I'll store these details, the product definition, product warranty, all these things. So in my customer service, I'll just continue developing that way. We are also going to see this in Swagger. Okay, that's very, we have long time to go to reach to that point. But for now, these are some technologies in Java which will, makes it easy developing the microservice. And out of all these technologies, we have seen Spring Boot is the actually the very major component or very major tool. So which made it very much easy developing microservices, or which actually I would say more than easy, reduce so much development effort with Spring Boot. But what is Spring Boot here? So before looking at what is Spring Boot, we'll just look at what is Spring, because yesterday you can actually, if I'm not looking at your messages, right? Yeah, we do have lots of JOX frameworks. I'm looking at charts so that I'll just answer some question. JC is one of them. You're right, Ramesh. REST easy, CFX, right? So JC basically, one of them, which actually, I would say Spring also adopted Jets. Of course, you still have few things. You know, I would say few hooks that you can just you know get linked and use REST easy way of thing. I'm still showing PPT, Srinivas. There's a question. I still see the PPT. Yeah, I'm still onto the PPT. So we have not yet jumped onto the code, but still, yeah. So as yeah, let's coming back to our conversation. So as many of you said, you are new to Spring, or some people doesn't have knowledge on Spring. Some people have not extensively used Spring. So let's have a very little discussion on Spring. Then we'll jump onto the Spring Boot. So Spring Framework. So why it is evolved? So before Spring Framework, the traditional approach of developing any Java application is using Java JV, Java double E, right? Java J2 double E, Java J2E, right? So these things, before Spring Framework, whatever the application. So let's say you are developing a web application. So now you have so many shortcuts, but before the Spring Framework, oh, it actually in JTU has all the concepts. So whatever the Spring Framework provides, JTU already has. So, but the problem is, it ended up doing lot many configurations and lots of coding. Let's say, you know, one of the core concepts of Spring is dependency injection or inversion of control. So what is dependency injection? What is inversion of control? Let's try to understand. So this is the only core concept that you can understand on Spring. Of course, Spring has some additional features as well, something called aspect-oriented programming, all that stuff. But if you want to learn Spring, you want to understand why, what is dependency injection and what is inversion of control. Both are generally same. So when you are developing an application using the core Java or traditional Java JTE framework, that is Java JTE framework, this is Spring framework. So one of the big challenge was, you know, addressing the dependencies. Now itself, we have seen customer service maybe at any point of time talking to order service, maybe order service at any point of talking to product and customer service. So these things are there, right? As these are talking, we cannot go and create a single class and just put all the methods into one class. That's not the way of developing, right? That's not the proper style of developing. Anyhow, we divided into modules. But what happened was, let's say in my product class, I need some customer. Okay, product, that doesn't make sense. Maybe let's say in my order class, I need product details, product and customer details, so that I'll place an order, right? Maybe a order class has access to order database. Otherwise, order class has methods which will actually go and access order related tables in the database. Maybe that order related tables requires at least some basic customer information, customer ID, customer name, and some basic product information, product ID, product, maybe product price. So before placing order record in the orders tables, this order service, otherwise the order class, let's assume in a regular three-tier approach only. Let's you know uh, come back from the microservices for some time. So order class requires some methods in the product class so that it will get the product information, some method in the customer class so that it will get the customer information. Let's assume this is a business case. What is a general way of getting those things? Maybe in your order class, you will create a product object. Maybe you'll just write a line saying, maybe in your order class, let's say, I have my class order, right? So then I need a product. So what do you do if you want to need a product? Maybe you'll write your this one, then user, okay, customer, right? Something like this you'll end up writing. So where you created an object. But what happened here is every time an order is created, right? You are creating a unnecessary new product object, unnecessary customer object. So all you might be wanted is like, let's say, something called something like place order is your method, let's say, and this may have got just a product ID, then a customer ID, so that so that it will place an order. But this this order may be requiring get prod name, let's say, to place in the orders table. It may, as per the logic, it might have received only IDs, but it may be looking for more details so that it will place in the right get customer name. So basically, what was the end requirement here? You wanted access to get product name, get customer name methods of these two different classes. So for that, if you just creating like this, so for every order, you're creating unnecessary product object. So after invoking this get prod name or get customer name, this prod object or customer object is nowhere used. So every time you execute a new statement here, this is a some Java basic here. So it will end up creating a new object. It won't give you an existing object. It will just create a new object. So to avoid this, what happened? There is something called singleton pattern is introduced. Otherwise, there is something called factory pattern. You might be knowing this. This is all again design patterns. So what would you do? So instead of, so you might have noticed after developing your application this way, you might have noticed, okay, this is creating unnecessary product objects, so many of product objects, because creating an object is a costly affair. It will consume your JVM space, right? So, and those needs to be cleared. So you might have realized, okay, it is creating unnecessary product objects, unnecessary customer objects. So then what would you do? So you'll create a singleton pattern or a singleton. You'll implement singleton pattern in your product class. So maybe your product class is like this. Okay, it's a different file, however. So far you may be having a new just a uh, right just a public constructor. So now what you do, you do a private, you make it a private, and you make it a static. This is implementing a singleton pattern, and so this will just avoid creating a new product every time, new object every time. And you'll just every time a product object is required, you'll make sure you have some way so that you are returning only the existing instance, existing object, so that using the existing object they can call these methods, get customer name. So similar stuff, similar singleton implementation. So here I would say, okay, I'm not going to write singleton implementation, that's fine. So so to avoid that, what did I do? So I had to write more code here. I had to implement singleton implementation, singleton pattern I had to implement. And similar to that, in customer also I had to implement a singleton in this one, singleton pattern, so that every time you can just if you are not aware of singleton, you can just maybe let's just look at web after this session. But what happening was, with a plain Java JTE kind of stuff. So to you know to rectify each of the problems, it is just making users or making developers to write more lines of code. Here, additional lines of code introduced. If you have just realized, to avoid creating a duplicate objects here. Again, in the customer, additional, maybe some singleton implementation here. If not singleton, let's say I want to create a factory. So what is factory? Factory pattern is something, something to create your objects based on some logic. Maybe you have some requirement based on your requirement. So you'll write some method, and that method basically returns your class object. So what's happening here? So lots of lines of code is getting added here just to solve one or duplication object. So in every class, we were like implementing singleton or factory kind of stuff. So this dependencies management is slowly what happened. When you started building complex applications with Java J2E, this dependencies management become lots of overhead. It became as an overhead. So Spring Framework, what happens? This basically addresses this. Now it gives you a container. Spring Framework gives you a container, and that container will basically take the responsibility of creating objects and maintaining the objects and killing the objects as well. So here, just for creating objects, I needed to take these many things, making it singleton, creating factory, all this stuff. But in Spring Framework, what happens is you have something called IOC container, inversion of control container. That container will create an object and will inject wherever your object is required. Let's say here I need an object. So instead of creating an object here, what you ask is I need a product object. You give me a product object. You'll give it on a singleton, or how you manage, how you create is your headache. I'm not going to worry, right? So here something you write a similar statement like this. Now the container will take care of creating an object. It's not your overhead. So this basically reduce lots of overhead on the developer as well on the JVM as well, right? It improves the performance. So basically we are injecting the dependencies whenever required. Now product is a dependency for the order. Product object is a dependency for the order class. So here I need a product class here, product object here. So how do I do? Earlier I used to create, now I'm getting it. I am not worried about creating. All I do is that is available via a common container. I'll just ask that container to give it to me. So container is taking the responsibility of creating the object. That's where this control got inverted. Earlier the control was in the dependent class. Now it got inverted to the container. So container will take care. So the objects which are created by container, created and maintained by container, generally we call them as beans. All nothing but creating an object. End of the day, we are creating an object. But earlier, what we needed to take care is, creating it as a singleton so that you won't end up creating lot many, unused objects and overheading your system. If you have more objects, more space is consumed. Your application may consume more CPU cycle. It gets stuck. All this stuff is there, right? So maybe if you look at from the smaller project like this, e-commerce project like this, you won't see it as a big deal. But in real time, you will end up creating. You generally create many complex applications. There, this dependency management becomes very much overhead. If you look at from this, it's a small project. It may not sound you as a big deal, but in real time it is a big deal basically. So Spring Framework mainly gained its attention by taking this control. Hey, don't worry, as a developer, you don't worry of creating an object. You just give me some basic configuration. so that I will see wherever your dependencies are required and I will inject the dependencies. All you need to do is you need to write a small statement like this. I need a bean of this. Whether it is via singleton or other stuff, you need not worry. Of course, there are few much very little configuration you need to do. So this is where dependency injection has come into picture. And with Spring Framework, not only dependency injection or inversion of control, we crossed the 8:30. But as I said, let's make some 5 to 10 minutes as cut off time. So not only so dependency injection and IOC is very core concept, very much core concepts used everywhere. Wherever Spring application is there, dependency injection and IOC plays major role. Additional to the dependency injection IOC concept, Spring also has some other features like this aspect oriented programming. So aspect oriented programming is another very big thing. Actually, reduce so much development efforts. So what is this is not only reduce, it makes your code cleaner. Aspect is something basically which which is not your business logic, but it comes across your different classes, different business logics. Let's say transaction management. So transaction management, what happens here? You may be having the order class, product class, customer class. Each of these classes, in one or the other way, they may be at one point communicating to database and creating some table, right? Some entries in the some tables. Maybe product class, they'll have product class has some methods to create a product record in the product table in your database. So there is a transaction happening with the database transaction are very costly here, right? So order also one or the other way keep communicating to database and creating some records. Customer, so whatever the generally business functionality, whatever the module you take, so end of the day, you just make some code, some methods, so that they're communicating to database and creating some entries in the tables and all. So every that's actually leads to every class here, what happens, every class is now worried on the transaction management. What is the transaction manager I need to use here? What is the transaction manager? Again, it's a DB concept, and but still let's assume, okay, transaction management is one concept, but this transaction management is required for all the three classes, because all the three classes are communicating to database at one point for creating a product or for creating an order, for creating customer, deleting product, all this stuff. So every time they do a database transaction management should come into picture. So now transaction management is called as an aspect. An aspect is something which cuts through multiple business logics. So with Spring, so these kind of aspects can be created and easily injected wherever you require. Let's say in the customer class, maybe you have a method which actually talking to database, maybe some SQL query it is executing. So to that method, before calling that method, you can just inject transaction management aspect there, which may be having some code saying, okay, all the upcoming instructions will be executed in a transaction. Maybe that the transaction aspect may be having this kind of a code, right? So okay, transaction management is not in our bucket now, but this is an aspect here. Transaction management is an aspect, logging is an aspect. These can be separated from your business logic. You need not as part of writing your add customer method. Let's say add customer is a business function here. So in that method you need not write the transaction management related code. It clumps up your actual business logic. Tomorrow, let's say a new developer has come in, he may want to introduce, okay, these lines of code is not related to business logic, these lines of code is from transaction management. Okay, this is where exactly a bug could be. Maybe this SQL gone wrong, maybe this DB creation, maybe this is pointing to a wrong table, all this stuff. So separating these things, that's again has its own advantages. So aspect oriented programming is another thing. Like this, the Spring framework has lots of different modules which actually reducing developers effort, not only reducing the developer effort, it is actually making developers to write efficient programs, more performance oriented programs. Let's say JDBC is there. Another 2 minutes I'll take. If you take a routine JDBC from Java JTE, right? So what you the developer is responsible. The developer is responsible to create a database connection and to close the database connection as well. Let's say I skipped. I'm a new developer. I'm a fresher. Otherwise, I'm a hurry programmer. You know, during the developing that method, maybe I just created a database connection and maybe write some statements to export SQL, then just close that method over there. I have not closed the connection. Java JTE doesn't have anything to close the connection, so that connection will be kept open until it maybe if you have by any chance if you configured connection timeout, until the timeout happens, the connection will be kept open. But JDBC with Spring JDBC that doesn't happen. Let's say if you even design, if you didn't configure connection timeout, or for every user call which entering into that method where a new database connection is created, so it will just keep creating database connection, but that connection don't get closed, that will get your database to hang. So that is the responsibility of developer in Java JTE. But it is now it become the managing of database connection become the responsibility of Spring. So these things are there in Spring, but mainly our concentration. If you are new to Spring, if you are already running Spring, that is fine. You may be knowing all these topics. But to learn Spring and Spring Boot, for now, dependency injection IOC is something that should you have in your mind. What is dependency injection and IOC is creating nothing but creating an object. Earlier, the dependent classes are responsible for creating the objects by looking at different methods that you know that the dependent otherwise the other classes are providing to create an object. But now the dependent classes are nowhere concerned about that. Dependent classes can go and ask a container to give a bin at any point of time. The container will take care of creating, injecting, maintaining, and deleting the bins. So that's where inversion of control. But to achieve this kind of situation, you'll just write little configuration. We'll see with an example tomorrow. So that's where a Spring overview. But if you still have maybe tomorrow we'll see an example on Spring and Spring Boot comparison also will do, so that we'll understand what is Spring and what is Spring Boot. But if you understand Java versus Spring, maybe you definitely you want to do some offline stuff there. So I'll stop it here for today. Tomorrow straight away we'll jump onto some programming, right? So we'll just start creating Spring Boot and all. But for now, I need a quick note for from who didn't get a chance to install STS. If anyone doesn't have STS, please make sure tomorrow you have STS in your mission. Right. So any questions? Please make sure to install STS and Maven. Actually, today it was required, but of course we didn't get a chance to jump onto the programming. And also GitHub sign up. Because I need your GitHub username so that I'll provide access to my repository. I have some sample examples so that you'll just clone them and start using. Any questions? Okay, if no questions, we'll stop it here. Thanks for joining today. So we'll meet again same time tomorrow.